Hello and welcome back. Okay, so we just wrapped up examples from chapter 1. That is the very basics of all math computation going forward. Assuming that that is grasped at any point, and if you question it, please go back and review those videos. We will be moving forward onto the lovely fractions. And before we get too far into fractions at all, we're going to understand two things, prime numbers and divisibility. So hopefully today we'll go over finding the factors of a number, determining whether a number is prime, composite, or neither, and determining whether a number is divisible by 2, 3, 4, 5, 6, or 9, which will be very important of trying to gauge whether or not you can, in fact, divide a number going forward. So, I understand from what we have previously worked with, such things are 2 times 5 equals 10, but what we call these things, where this is our product, 2 and 5 are our factors. So to find the factors thereof, let's go with an example of 18. To list all the factors is to go through and see what multiplies by what to get 18. So we're going to start with 1 and count upward. So 1 times what is 18? 1 times itself is 18. So 1 and 18. 2 times what? 2 can fit into 18 9 times. We'll go up to 3. 3 can fit into 18 6 times. Can 4 fit into this? 18. It cannot without a remainder. So because it has a remainder, we don't consider it. 5, can 5 fit into 18? No, it cannot, not without a remainder. And then we come back to 6, which if we have 6 here, 6 times 3, which this is the exact same. We have come full circle, as it were. And these are our factors. So our factors of 18 are thus 1, 2, 3, 6, 9, and 18. All right. So listing the factors, one more example, we have 24. My process, and what I am showing you, is simply counting to get through all the factors of a number. So 1 and 24, that's a given. We have 2 times 12. We have 3 times 8, and all of these should equal 24 if you were to multiply it back. We have 4 times 6. 5 cannot fit without a remainder, and that brings us back to 6. So these are our factors. 1, 2, 3. I am writing what I am reading as opposed to what I am saying. I'm sorry if that is distracting. So we have 1, 2, 3, 4, 6, 8, 12, and 24. All right, so this begins the concept of the difference between a prime and composite number. A prime number and knowing this before we do much more computation work, is any number, any whole number that has exactly 2 factors 1 and itself. A composite number is any number, any whole number. I want to put an asterisk here because it can be any integer, but we haven't described what an integer is yet. So a whole number is just going to have to be a placeholder in this statement. So a composite number is any whole number that has more than 2 factors. So from our previous example, 18 and 24 are composite numbers. But an example of a prime number would be that of, let's say we have 23, and we go down the list. We have 1 times 23. 2 can't fit into there evenly. 3 can't fit into there nicely. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way up to 23. So can 15 fit in there? No. 16, no. 17, no. No. 18 or 19 or 20 or 21 or 22, but only 23, and that comes back to 1. So the only 2 factors of 23 is 1 and 23. So that means that 23 is a prime number. Okay. So this leads to a fun idea, especially with prime numbers. Prime numbers are very special in the number universe. We can't predict when they occur as far as counting them, so we have to just evaluate them where they are, from where they're at to where we can verify that they are in fact prime. So let me give an example, if I may, of an idea. So we have a box for 1, 2, 3, 6, 7, 11, 12, 13. And I'm gonna do one more row. So that'd be 41, 42, 43. So what I've simply done here is counted from 1 to 50 in a sort of kind of square box shape. Now without including 1, because 1 is in and of itself a very, very special number. So we know that 2 is a prime number because its only 2 factors are 1 and 2. But anything that's a multiple of 2, that is 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and so on, are composite numbers because they are a multiple of 2. So we can mark them out as possible prime numbers. Three is also a prime number because it is only a multiple of 1 and 3. But any multiple of 3, that is 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so on, are composite because they are a multiple of 3, and we can mark them off the list. 6 is already gone. 9, 12, 15, 18, 24, 27, 33, 39, 40, 45. Yep, okay. So we marked 4 off. 5 is prime. In the same way, it's a multiple of 1 and 5, and any multiple of 5 is therefore also a composite, and so on and so forth. 7 is therefore prime. 7 and 2 is 14, and 3 is 21. 4 is 28. 5 is 35. 6 is 42. 7 is 49. 8, 9, 10, 11 is prime. So this is how a person or a computer systematically goes through and finds primes. So anything of 11, which would be 22, 33, 44, 55, and so on, would find primes. So then we have 13 as prime, 17 is prime, 19 is prime, 13 times 2 is 26, and then 13 times 3 is 39, 17 times 2 is 34, 17 times 3 is 51. So we're starting to get too big to do too much else, and just the 50 numbers we're having. Like we said, 23 is prime, as we have seen earlier, times 2 is 46, and then 29 is prime, times 2 is 58, and that goes outside of our range, so then everything else would be prime in this particular set. And as you get bigger, it gets harder and harder, or it takes longer and longer to find out if a number is prime. So that being said, now we talked about prime and composite, but the notable exceptions to this are the numbers 0 and 1. Because 0 can equal anything times 0, it technically has an infinite amount of factors. So that makes it not prime. But because they're not necessarily differing factors, so if 48 times 0 is 0, 17 times 0 is also 0, that's something times itself, which isn't necessarily the definition of a composite either. So that makes it neither prime or composite. And 1, the lovely thing about 1 is that 1 is a lovely thing. So 1 equals 1 times 1. And technically, 1 times 1 times 1 times 1 times however many ones you want to multiply it by. It is 1 times itself because 1 is itself. And then there are more than just 2 factors here. So again, it's neither prime nor composite. So the notable exceptions are 0 and 1 are neither prime or composite. Okay. Going forward, to discover if it's indeed a huge number and you can't take the time to divide it by a number you want to see if it's divisible by, there are some shorthand attempts to verify it if it's divisible by the number you're looking at. So if it is divisible by 2, so it is divisible by 2 when the last digit is either 0, 2, 4, 6, or 8. And this is because 0, 2, 4, 6, or 8 is even, and any multiple of 2 will be even. So an example of this, we have 2,346. Is it divisible by 2? There's a 6, so yes, it is. We have 13,254. Is it divisible by 2? It ends in a 4, so yes, it is. We have 23,573. Is it divisible by 2? No. First of all, by the inflection in my voice, but second of all, because there is a 3 here. And 3 is not on the evens list, it is in fact odd, so no, it is not. And we are also given 57,085, which 5 is not even, it is odd. It is not 0, 2, 4, 6, or 8, so it is not divisible by 2. Knowing if something is divisible by 2 is very nice and easy just by looking at the digit and whatever that value is. Now, I like finding things that are a little more complicated, such as, is it divisible by 3? Things are divisible by 3 when the sum of the digits in the number is divisible by 3. Which this seems kind of convoluted. To find out if it's divisible by 3, first the sum of the digits has to be divisible by 3. Well, we can do this as an example. So we are given the number 345 as an example. So 3 plus 4 plus 5. 3 plus 4 is 7. 7 plus 5 is 12. And if you really want to, if this is still too big a number, you can do this again. 1 plus 2 is 3. Is 3 divisible by 3? Yes, it is. So, yes, it is. We also have the number 1,243. 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 3 is 10. And, again, if this number is still too big, 1 plus 0 is 1. 1 is not divisible by 3. 10 is not divisible by 3. So 1,243 is not divisible by 3. And one more example we have is 25,368. So the sum of its digits would be 2 plus 5 is 7. 7 plus 3 is 10. 10 and 6 is 16. 16 and 8 is 24. And 2 plus 4 is 6. 6 is divisible by 3 because it is 2 times 3. So 24 is, and 25,368 is divisible by 3. So it's a little more convoluted than the 2, but I hope that makes it more intriguing. I know it may or may not be, but it's very much quicker than just dividing the given number by 3 and seeing if there's a remainder or not. And then, to round out today, because there are a few left to go. Oh, we'll go a little long. It'll be fine. So we did the divisibility of 2 and 3. So now we are going to find the divisible. So blurry. There we are. We're going to find the divisibility of 4. And that is when okay, simply put, a divisibility of 4 is when the last two digits are divisible by 4. It also states that a whole number is divisible by 4 if division by 2 leaves an even quotient. However, simply looking at the last two digits of a number will verify if it is indeed divisible by 4 or not in much the same way. I find looking at the last two digits faster than dividing by 2 and discerning an even or odd quotient. So the examples herein is given 1,464. We're going to look at 64. 64 divisible by 4. 4 can fit into 6 once. Minus 4 would be 2. And 4 can fit into 24 3 times. No remainder. No remainder, this number is divisible. We're also given the example 2,434. We're going to look at 34. 34 divided by 4. 4 cannot fit into 3. 4 can fit into 34 8 times. That is 32. But then that leaves us with a remainder. So this one is not. This division, although we're still having to divide, is much more simple than dividing the given number by 4. We'd have to go through everything in front of the last two digits to get there. So this is succinct and hopefully simple. Divisible by 5. Is when the last digit is 0 or 5. So in the examples of 22,100, it ends in a 0, so yes, it is. We have 6,456. It ends in a 6, so no, it's not. Divisibility by 5 is very simple. Probably the simplest, arguably. I also have the example of 245. It ends in a 5, so yes, it is. And so on and so forth. 0 and 5's divisible by 5. Divisibility by 6. Is when a number is both divisible by 2 and 3. Or you could say that it is even and divisible by 3. So because we know how to check for divisibility of 2 and 3, we use those methods to discern if it's divisible by 6. We have the numbers 6,456. So then 6, this is even, so we have one of the criteria made. 6 plus 4 is 10, plus 5 is 15. 15 plus 6 is 21, which is divisible by 3. So both criteria are met, and this is divisible by 6. We have another example of 242, which it is even, so it matches one of the criteria to be divisible by 3. 2 plus 4 is 6, plus 2 is 8, which is not. And because one of the criteria is not, the whole number is not divisible by 6. And then we have 22,103. And right away we can tell that it is not divisible by 2 because it is an odd number. So then the whole number is not divisible by 6. And then lastly, we did have time. Good. Divisibility by 9 is when, very much like divisibility of 3, when the sum of its digits is divisible by 9. So, given the examples of 3,456, we sum the digits. So 3 and 4 is 7, and 5 is 12. 12 plus 6 is 18. 18 is divisible by 9, so this whole number is divisible by 9. We have 243,000. 2 plus 4 is 6. 6 plus 3 is 9. 9 plus 0 is 0. 9 is divisible by 9, so this whole number is divisible by 9. And then we have number 22,205. So 2 plus 2 is 4, plus 2 is 6. 6 plus 5 is 11, which is not divisible by 9, so the whole number is not divisible by 9. Yes. That completes, as far as prime and composites, divisibility section. We covered the whole thing. Something I would like to add, if I may. Gonna move everything a little out the way. My favorite thing, and it's okay to use your hands to multiply and add and divide. Please use your fingers to count when you may. Multiplying by 9, in any case, I would like to teach you the finger method because it's kind of fun. 1, we're going to count on our pinky. So 1 times 9, curl that pinky down, is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the pinky, or the finger that is bent down, is the difference between the tens place and the ones place. So anything to the right of the bent finger is in the ones place, and anything to the left will be in the tens place. So 1 times 9 is 9. 2 times 9 is 1 in the tens place, 8 in the ones place, is 18. And then 3 times 9 is 2 in the tens place, and 7 in the ones place. So it would be 27. Sorry, let me scooch over. And then 4 times 9 would be 36. 5 would be 45. 6 would be 54. 7 would be 63. 8 would be 72. 9 would be 81. And then 10 would be 90, because there's nothing after. It'd be 0, and it'd just be 990. So when in class or wherever that you need to multiply by 9 by 1 through 9, you can use your hands to do a quick calculation, like what's 3 times 9? Well, that's 27. Easy peasy. I just thought you would find that quite interesting. In that case, any questions, comments, concerns? I know this is a short video going into the new section on fractions. We haven't even gotten into the fractions, but hopefully we will find something more fascinating soon. Thank you.